Welcome at PAS 2024 at ETH Zurich. I'm here with Demostinis Pasadakis from Università della Svizzera Italiana and Albert Ian from YA. So welcome. We're chairing a mini-symposium at this PAS conference. So what was this mini-symposium about?
So our title was High-Performance Graph Analytics, and our goal was to sample both theoretical and applied work in the area of learning graphs from data, analyzing graphical structures after you have them, and also speeding up algorithmic operations by considering graphical operators within these algorithmic frameworks. And yeah, we had 4 talks in the mini-symposium. Albert Jan from Huawei gave a very nice talk about that. That was the general theme was that operations on graphs, or how do you utilize graphs to speed up algorithmic operations?
So you had your discussion, and if you had to summarize the most important message from the mini-symposium, what would that be?
Right.
What do you think?
So graphs, most of the data that you see in practice are from the use of social media, but also from, for example, drug discovery or other sort of applications. The graphs that you see there become increasingly bigger, right? And in order to be able to properly analyze and draw conclusions from this sort of data, we need new algorithms. And those algorithms need to run on novel architectures, state-of-the-art supercomputers, as well as, for example, wafer-scale architecture. So we had 2 people giving talks about that in the mini-symposium. So I think that's one of the main takeaway messages. The data is becoming increasingly large. To process it, we need smarter algorithms, sometimes randomized algorithms if you look into graph neural networks and so on. These need to run on different types of architectures, and to make all of this easy, we need simple to use frameworks in which you can implement all of these algorithms that then ideally automatically
Was your mini-symposium actually really interdisciplinary? Did you have thoughts and ideas from
the applications or the test cases that were used in the different talks were interdisciplinary, but at the core, we were focused on development on graph algorithms. Now, how are you going to use that? As Albert Jan said, your test case could be a social network, your test case could be detecting anomalies on financial transactions, it could be various things, it could be training a graph neural network. So the interdisciplinarity was coming at where are we going to apply these high-performance graph algorithms?
So if I was a funding agency and you would have to convince me to keep funding your research and your development,
right?
What would you tell me?
I'll answer on my behalf how my thoughts are on that. I think we indeed live in an era where data is becoming increasingly bigger and more complex, and being able to capture interdependencies with a graphical structure that captures who is connected with whom and what is the relationship of that entity with its neighboring entities, for example, is very important because exactly the data becomes bigger and becomes more complex. So we need to have better insights on these complex structures. And this would be my initial pitch to a funding agency.
Right.
What do you think?
So from maybe a more company sort of perspective, what we're looking for is maybe not the applications, but rather what kind of hardware we can provide for it. And this sort of application area touches on storage as well as the compute. So do you want to mix AI in this? Do we want to use AI accelerators? Do we need distributed storage? And if you use large-scale compute, networks and so on become important as well, right? So, and as Dimos was saying, this area is becoming increasingly important. So for sure, there is a demand for specialized hardware and systems in this area.
So thank you very much, Albert and Demostinis, and good luck, and maybe see you at the next PAS conference.
Right.
Thank you.
Yeah.